Hey, it's Calc&Compile, your shortcut to simple math and computing. In this question, a set A is given which is A equal to 1, 2, 3, and the relation is given which is 1, comma 1, 2, comma 2, 3, comma 3, 1, comma 2, and 2, comma 1. We have to check whether this relation R is reflexive, symmetric, antisymmetric, and transitive. So, a relation on A is reflexive if A comma A belongs to R for every A belonging to A. Here A equal to 1, 2, 3. So reflexive pairs are 1, comma 1, 2, comma 2, and 3, comma 3, which are present in R. So R is reflexive. A relation is symmetric if for every ordered pair A comma B belonging to R, then the pair B comma A should also be in R. For 1 comma 2 belongs to R and its reverse 2 comma 1 is also in R. Similarly for 2 comma 1 in R, its reverse 1 comma 2 is also in R. So R is symmetric. A relation R on a set A is antisymmetric if for every pair of distinct elements A comma B belonging to A, if A comma B belongs to R, then B comma A should not be in R. In other words, if both A comma B and B comma A are in the relation R, then it must be that A equal to B. Here 1 comma 2 belongs to R and 2 comma 1 also belongs to R, but 1 is not equal to 2, therefore R is not antisymmetric. A relation R on a set A is transitive if for every A comma B belonging to R and B comma C belonging to R, the pair A comma C must also be in R. Here 1 comma 2 belongs to R and 2 comma 1 belongs to R, and for the relation to be transitive 1 comma 1 must be in R and it is. Similarly for 2 comma 1 and 1 comma 2, 2 comma 2 is in R, so R is transitive. Therefore the relation R is reflexive, symmetric, and transitive but not antisymmetric. In this question we have to prove that R equal to x comma y belonging to z comma z such that x congruence y mod 5 is an equivalence relation. So a relation is an equivalence relation if it is reflexive, symmetric, and transitive. So a relation is A on A is reflexive if A comma A belongs to R for every A. So for any x belonging to Z, x minus x is equal to 0 and 0 is divisible by 5. So x comma x belongs to R for all x, therefore R is reflexive. For a relation is symmetric if for every ordered pair A comma B, the pair B comma A is also in R. Suppose x comma y belongs to R, that means x congruence y mod 5 or x minus y is divisible by 5. But if x minus y is divisible by 5, y minus x is also divisible by 5. Therefore, y comma x also belongs to R. So R is symmetric. Now a relation R on set A is transitive if for every A comma B belonging to R and B comma C belonging to R, the pair A comma C also belongs to R. Suppose x comma y belongs to R and y comma z belongs to R. That means x minus y and y minus z are divisible by 5. Now on adding them we get x minus z, which is also divisible by 5. Therefore, x comma z belongs to R, and the relation is transitive. Since the relation R is reflexive, symmetric, and transitive, it is an equivalence relation. Thanks for watching. Don't forget to like, share, and subscribe. See you in the next one.